All right, it's Coach Stricker. I'm here to talk to you guys about the quantum model and how it was set up, but most importantly, these scientists, okay, when they studied light to find out about electrons, all right, they didn't agree on everything. Remember, Planck in his posse talked about light being a particle. Okay, Schrodinger, okay, his guys all talked about light being a wave. Okay, and then de Broglie is a scientist that came along and he said, hey, it can be both. And he did the duality of light. Okay, and the duality, dual means dual nature, two natures of light. So it can be both a particle and a wave. And there's experiments that support both of those hypotheses or theories. All right, now when we're talking about a wave, all right, remember a wave, okay, it looks like this, kind of like a, there are two different types of waves. These kind of waves are like a slinky wave, that's like this. But we're talking about these waves, the longitudinal waves, okay, and it has a crest and a trough, and one wavelength, okay, includes one crest and one trough, all right, and the wavelength is the size of the wave, all right, the size of one wave is called a wavelength. It is measured in meters, okay, with the abbreviation of M, and the symbol for wavelength is a lambda sign. Okay, and that lambda sign is like an upside down Y. So when we talk about wavelength, talking about the symbol lambda. Frequency is how many waves per second go by a certain spot. All right, it is measured in what's called hertz. All right, the abbreviation for hertz is Hz, or it's 1 over a second. And so you're going to see the 1 over an S, which is the same thing as a hertz. And the symbol for frequency is a V. Okay, a V. I guess F was something else, like focal pointers or function. So that's not, you'd think it would be F, but it's not, it's a V. All right, and we're going to do math problems with that later, and you're going to see that. Now, as far as waves go, when they were studying waves, the scientists came up with the electromagnetic spectrum. It's on page 120 in your book, all right? And it shows the different waves. And the thing about the waves is you can look at their wavelengths and their frequencies and how they fit in order. So you're going to have to understand the trends that you see on this table we're going to create right here. And the ones that have the longest wavelengths are farthest to the left. So the ones that are farther to the left have longer wavelengths, but they have smaller frequencies. Okay, so smaller frequencies, but longer wavelengths. All right, so the ones to the left are that, and that makes sense because if you look at it, if you have a really big and long wave, you're not going to have a high frequency wave. But if you've got a wave that's small, like that, that is a high frequency wave, but it has a really small wavelength, all right? And then the last thing we're going to learn with that is the energy is directly proportional to the frequency. So if it's a high frequency wave, that wave is very high in energy also. And we'll see that in a minute. And if it's a low frequency wave, it's got low energy. All right, now the lowest or the smallest wavelength is going to be radio waves. So you'll see that. Radio waves have the smallest wavelengths, and that includes AM and FM. FM's a little bit longer than AM. All right? Then the next one is a microwave. What do we use microwaves for? Cooking, right?
No, not really.
Yeah. Well, radio waves, what do we use those for? Cell phones, right? There's radio towers, TVs, signals, all sorts of stuff like that. All right? And then, and it's interesting because, a real life thing here that, they did like a study in like the 1930s and took a picture of the radio waves in the air. Okay? And the radio waves, it was just like, you could see in the air, like, there's just a couple waves, whatever. Then it was like 1990s they did it, okay, when they started developing more TV, everybody had more TVs, and cell phones started to come on. And then now with the cell phones and the TVs and all that stuff, it's black above us. Like totally black. Like it's like this huge radio wave thing above us. Because all the radio waves travel, right? Everybody's cell phone's emitting a small radio wave. Well now, like I said, above us it's just completely black. Now, Do radio waves cause cancer? I mean, probably not, okay? But it's like when the, does, artificial sugar cause cancer? Well, if you just have one artificial sugar packet in a day, you're not gonna get cancer from that. When the rats get it, they pump them full of tons and tons of artificial sugar, and then they all of a sudden start growing tumors out the side of their heads, stuff like that. Well, we're gonna see what happens, long-term effects of everybody having a cell phone next to their ear and an iPad in front of them and watching TV. I mean, you're just like triple dosing yourself full of radio waves all the time. We don't know the long-term effects of that. So you guys all die when you're 60, it was probably not a good idea. Just saying. Yeah, microwaves, okay? Microwaves, obviously they cook our food. They're more high energy waves than a radio wave, right? Which makes sense. It follows our trend because the farther to the right, the higher the energy. The farther to the right, the higher the frequency, okay? Then we have infrared waves. Infrared. A lot of you guys that play those video games like, Battlefront, and you can go to infrared glasses and you can see people and their heat signatures and stuff like that. If you've ever seen the movie Predator, the things like whoosh, and then you can see the people's heat signature and stuff like that. That's infrared waves, all right? We can't see that with our naked eye. We have to have special goggles for that. Now, what we can see is called the visible light spectrum. All right, and visible light, all right, is the wavelengths are a little bit shorter than infrared, because remember, as you're going from left to right, the wavelengths are getting smaller. The frequencies are getting higher, and the energy is getting higher. Well, the visible light spectrum is this little sliver right here. And that's the only spectrum that we can actually see. All right, and what can we see? We can see the rainbow of colors. So Roy G. Piv, red, orange, yellow, green, blue, indigo, and violet. Those are the colors in a rainbow that we can see. All right? So what about black and white? That's what somebody asked last period. Well, black is absorbing all of the colors but reflecting none, and white is reflecting all colors. That's why if it's hot outside, and it is in Texas, you want to wear white because it reflects all the rays of the sun and doesn't absorb any of them. Where black, it absorbs all the rays of the sun. So it makes you hotter. All right. Now, it's important to understand that the colors of the rainbow follow the same trend as the whole spectrum. So the colors that are farther to the left have higher wavelengths or longer wavelengths, and they have lower frequencies and lower energy. So what's the least energy color out there? Red, right? What's the highest energy color? Violet. What's the highest frequency wave? Violet. What's the smallest wavelength? Violet. All right, so they're in order from longest wavelength to smallest wavelength, lowest frequency to highest frequency, lowest energy to higher energy. All right? Now, the next one is called ultraviolet rays, or UV rays. You've heard that before. Now, ultraviolet or UV rays will kill you. Okay, that's anything past visible light will kill you if you have enough of it. It'll damage your cells, give you cancer, go on. Now, UV radiation is from the sun, right? That's why if you get a bad sunburn, okay, you get another bad sunburn, you get another bad sunburn, okay, it's not good for your skin. You can get cancer and it messes it up. All right, the next one is X-rays. What happens? Where do we have X-rays at? Doctor's office, right? Or, go get your teeth cleaned and they take an X-ray on your teeth. They put that lead jacket on you, or the lead blanket thing. Why do they do that? So your body does not absorb a lot of X-rays. It's not good for your cells. All right? So they zap the spot that they're looking for, and it makes your bones glow, and that's where the color and the white on the film comes back, because your bones are glowing because they zap it full of radiation. All right? That's why you don't want to make sure you have the blanket on. All right? Now, then the last one's gamma rays. All right? Now, gamma radiation is the strongest. It's the highest energy, highest frequency wave. That's what they use in weapons. Okay, they have these new tank buster bombs. Like if you're at, you know what the average lifespan of a tank is in a war nowadays, like an engaged war? 3 minutes. It used to be back in the day, you watch all those old videos, World War II videos, I mean, you're rolling in the tank, dude. I mean, you're just rolling. Like, nobody's messing with you. I mean, they're shooting you, it doesn't matter because it's deflecting off your tank. You know, it would take, like, them messing your tires up and then somebody getting on top, opening the hatch and putting a grenade in it or something to take care of the tank. Now, I mean, they've got drones that paint the tanks, and then they fire the missile, and then they can paint the target with the drone, and the missile goes right towards the tank, and they're tank buster weapons. So they hit the outside, then the gamma radiation melts the metal, and then it delivers the charge on the inside. So think about that. If you're in, you know, if you're in the Iraqi war or whatever, and you're riding around your tank, you're thinking you're all good, oh, Americano and whatever, and all of a sudden you hear you're like, oh no. It's like, and blows you up from the inside. All right, so this is the electromagnetic spectrum. All right, radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Okay, you need to know that order because they're going to ask you on quizzes and tests. Put these in order of smallest wavelength to longest wavelength. Put these in order of shortest wavelength to longest wavelength, whatever. They're going to put them in order. So if I give you, let's say I give you microwaves, X-rays, red light, and ultraviolet, UV rays. Put those in order of shortest wavelength to longest wavelength. So which of these has the shortest wavelength? The shortest wavelength is the one that's farthest to the right. So what's that going to be?
Red light.
X-ray. So that's number 1. Then what? UV is number 2. Then what? Red light's right here. It's in the visible spectrum. So that's 3. And then microwaves would be 4. So shortest wavelength to longest wavelength. Now, what about smallest frequency to highest frequency?
CHS. I'm Malika Samnani.
All right.
Smallest
frequency. Go ahead and hit pause.
Will you please stand for the pledge?
Hit pause.
Can't pause it.